So LeetCode 605 can place flowers. In this problem, you're given an array flower bed containing zeros and ones, and 0 means empty, and 1 means that there is already a flower in that position. And you're also given the integer n, which is the amount of new flowers that you need to plant in the flower bed without planting adjacent flowers. Okay, so to solve this problem, you can just do a greedy solution because basically every choice that you make locally, it doesn't affect like the rest of the problem. Like for example, if we have a run of consecutive zeros here, like no matter how we plant the flowers here, if we plant them in the optimal way, like we plant the optimal amount of new flowers in this run of zeros, then like if there was another run of zeros after this one here, this other run of zeros wouldn't care about what we did here. Like essentially anytime you meet a 1, you're basically resetting everything. It's almost like if it was a new problem. So that means that if you do the thing correctly in the local run of zeros, then you're good, okay? So yeah, we're just going to implement that. So we're going to loop through all of the positions in the array one by one with a for loop like this. And at every step, we check if flower bed of I is 1. If it is, then we just continue because we cannot do anything if there's already a flower planted, right? So if flower bed of I is 1, we just continue. And then what we do is we find the longest run of zeros starting from this position. So like from now on, we know that if we didn't hit this continue, then we are on a 0. So we want to find the run of zeros. So basically we want to stop looking for new zeros when either we get to the end or there is a 1, right? So that will give us like a sliding window, a window of all the zeros. Okay, so we start with 1 position being available, which is the current one. Although if your previous position has a 1, then you cannot actually place a flower here. So like this run variable wants to keep track of how many positions we can actually plant a flower in. And so like by default, it starts with 1, because maybe like we have an array with just 0, so we have just one element which is 0, then we could place a flower there. But if you have like a 1 before, like in this case, then you don't have actually one position, you have one less, because you cannot place flowers here. So you need to remove your initial 0 in that case, right? So the initial run is 1 minus the flower bed of I minus 1 is equal to 1, okay? So we just subtract from 1. The flower bed of I minus 1 is a flower. There's already a flower there, so we cannot put a new one here. Okay, so this is the beginning value of our run. And then we just do a while loop. So while the next position doesn't have a flower, and actually more precisely, while the next flower bed position is exactly a 0. So this also takes care of the case where we go out of bounds, right? So while it is, then we can, first of all, increment I and also increment run. So increment the variable that keeps track of how many positions we can actually place a flower in, okay? And now at the end, you need to kind of do the same thing that we did before. Like if we get to here, we can see that the next position is a 1. And so that tells us that we cannot actually place a flower here. So we need to remove 1 from the run variable if the next position has a flower, okay? So for example, you wouldn't have to do this if the next position were just out of bounds. Okay, and now what you do is you need to calculate how many flowers you can actually place in this run that we've calculated. Like for example, in this example here, run would be 1. Okay, so how many flowers can you place if you only have one spot? You can place 1 flower. How many flowers can you place if you have 2 spots? You can place still 1 flower, because else you'd be placing adjacent flowers, and you cannot do that. And what if you have 3 places? Then you can place 2 flowers, and so on. So I just ran that through my mind, and I noticed that the formula, the correct formula to place flowers is just dividing the places, the available places that you have by 2 and sealing that, right? So taking the nearest integer that is greater or equal to the result of the division by 2. So if you have flowers, like because this could bring that to 0, then you decrement the amount of flowers that you still need to place by the ceiling of the division of run by 2. So like if you have 10 places, then you can place 5 flowers. And also if you have 9 places, you can still place 5 flowers. Okay. And then at the end, you just return if n is less or equal to 0, meaning that you've placed at least n flowers, then you return true. But if n is still positive, then you didn't place n flowers, and so you need to return false. And one other thing is you could place a short circuit here. So as soon as you notice that you can place n flowers, then you return like this. So when you realize that n is less or equal than 0, even if you're still in the for loop, you can still return true. Okay, so I'll submit a solution to show that it works. And the time complexity here is O of n, because you just go through each element once, even though you have 2 nested loops, because you do I++ anyway. Like, it's not like we have a different index. So we're still using the same index, and it always only goes forward. So you only go through each element once. And the space complexity is O of 1, so that's optimal. And depending on if you allow to edit the input or not, this is kind of the only concept or way of doing it without actually occupying new memory. Because if you don't allow editing the input, then you'd have to make like a copy or something like that, and so you'd be using O of n memory. So that's it from me today. Thank you for watching, and bye.